And if you see, the top of the table has one color, and other parts there is another color which is same as chair color. So if we use the color which is happening here, we cannot use color to discriminate the two objects, because color is same for both the objects, but this color, if we take, this is different than that, so that information can be used to separate or identify by computational methods to distinguish them. Okay. So if this is black, even it can distinguish even in a better way. So entire numerical analysis or artificial intelligence or machine learning, what we study, it is completely 90% of it is on discrimination, finding a parameter which will discriminate the two objects as well as possible. That is a question. Okay. So these are the things which I will be discussing. Then coming to some background, world is facing global technological advancement. It is a large evolution. Okay. So technological advancement is taking a larger step today. In every field of engineering, science, management, entrepreneurship, human resource management also, technological interventions are there today. Even in our education also there are technological advancements. So OBE we are practicing. We can use some data analytics method to make a better analysis of our data. That is also possible. So in all fields, even medicine also, to validate their results and findings, statistics is required, and these computational methods are much useful even for doctors, even for managers, even for human resource officials. Everywhere data is required. Even at government levels also. Even if you see crime, the local police station, they will take necessary action. And as you go higher and higher, it is more on statistical rather than field work. So in which area there are more crimes and who is posted there, what extent crime is controlled there, and suppose there is another similar area, which official has to be sent there, all those decisions can be made using statistics. Okay. So world is facing technological revolution in all aspects of science, engineering, management, human resource, whatever, even law also it is used. Even if you go to some law, if a lawyer needs some cases of particular nature, he want to search. We don't have a context-based search mechanism so far. In future it may be available. But for our research papers, we can search keywords and we can fetch the data. But if you go to, government also has a website ecourts.gov.in, where you can search based on the party name, based on the particular act, or based on a date, or between the window of a date, etc. can be searched, or number, etc. But we cannot search how we search in Google to find out some soil chemistry study. I can search some papers I may get. So like that, a lawyer want to search some cases in a particular court on particular topic, that such tools are not. That also can be applicable. So boundaries defined by the traditional science are almost extinct. Okay, if you go to IITs and all, they do more on interdisciplinary research. Even foreign countries also, they do interdisciplinary courses. And even doctors also, they study technology today, because frontline doctors, they work with the patient and analyze and they will treat them. But when you go to higher levels, resource mobilization for healthcare or what specialization is required, all those analysis is done again using the statistics. Practically speaking, even some people say that doctors and engineers, there is no difference. When you go to solve a problem, there is no distinction. That level things are going on today. So interdisciplinary nature is very much, and today solutions are driven by interdisciplinary. Even PhDs also, everyone is doing interdisciplinary PhDs. And if you go to core things like algorithm development or physics, chemistry, most of the things are established. So only remaining is interdisciplinary nature of the data. There you can find out something new, and that will be a new solution, innovative and first of its kind, that will be useful to many consumers. So as a consumer of engineering product, his needs have to be met through technology which the engineer develops. Then consumer point of view, underlying technology is a black box. He don't know how I solve. He just will see the solution is there or not, whether the solution developed meets his expectations or not. Only that the consumer needs. And engineering is product is designed based on social relevance and need. Whatever problem we identify, it should help a large number of people, and it should have a large scope, and when it has more number of people, that has more social relevance and more impactful. That research will be more impactful. A useful product or technology for a consumer, generally a combination of many fields. Some examples also I will be discussing. Yeah. So interdisciplinary research is a mode of research by teams or individuals who integrate the information, data, then techniques, tools, perspectives, concepts, theories from multiple disciplines or multiple specialized areas to advance fundamental understanding or solve problems whose solutions are beyond the scope of single discipline. This is a formal definition of interdisciplinary research. So they involve combination of multiple fields, etc. For example, in electronics, students study signals and systems, then they study digital signal processing, then they study speech signal processing, medical signal processing, and all they study. And when you come to civil engineering, if you go to geology field, you get a lot of seismic signals. I think the civil engineering people are aware of seismic signals. They are just variations with respect to time, continuous waveform we get, and from that waveform we have to understand whether there is an impending possible earthquake, tsunami or whatever, some plate movement, all those things can be understood. There are also all the techniques which easy students study, such as DSP, signals and systems, Fourier transform, wavelet transform, time frequency analysis. All those things are also used in geosignal processing. So there is no distinction between different fields, and as an end user, he wants a solution for his problem irrespective of the domain of the engineering. So interdisciplinary studies involve combination of two or many disciplines. And yeah, this way I can express civil engineering is there. Then we also have mathematics and computational science, then data science and analytics. Three fields I have here. Civil engineering is one field, mathematical and computational science is one more field, data science and analytics is one more field. Now at the intersection of these three fields, that is this area, this grey area, which is present in common in all three disciplines, this is where we have to do something, and this will be interdisciplinary research, this area. Example is geosignal processing, where seismic signals can be acquired, which can be analyzed, and all tools which were studied in electronics or instrumentation engineering, such as signal processing, then signals and systems, then wavelet, time frequency analysis, etc., can be used to understand the seismic signals, and one can take a decision whether there is an impending possible earthquake or not. All those things can be understood. So disciplines doesn't matter, the problem solution is more important. Yeah. So different paths for interdisciplinary research projects are these. One is by observation, one is by literature search, one is by analysis of limitations of existing technology, and or combination of these three. So this way we can have some interdisciplinary problems. So by observation we can do, literature search also we can do, analyzing limitations of existing techniques as well as combination. It is possible. One example I can give, we can walk outside on any street. We may find in the morning 6 o'clock or 6:30, if you walk, we find lot of street lights are on still, even though sun is good. So one can develop a solution, automatic on or off, mechanism can be incorporated. With that, lot of energy can be saved, which still in our country we have not reached all houses in remote villages with electricity still now. So they can be given this electricity and it can be saved in cities streets. So all those things are the, yeah, that is by observation. Literature search means searching the publication so far, what are all there, with which we have to do an analysis, which literatures are published on that topic and what they worked, what they achieved and what are their limitations. This we have to list for related papers, and then we have to take it in front of us as a table, and then we have to think completely so that these people have done these things. What is remaining to do, that we have to think and we have to formulate, and that is called problem statement. Okay, so using literature search also we can do. Then analysis on limitations of existing technology, that also we can do. As well as there may be a solution available in other countries which is expensive to import and use in our country. We can find out a similar technology which may be equal efficient or less or more also, and which we can bring it for a lower price, which will help many people in our country. So such solutions also can be done. So it is in general. Okay, then steps. Steps of interdisciplinary research based on observation. Simplest example I told, traffic, this street lights which we can automatically off, or we can see there are a lot of road problems and traffic problems, etc. are there, and there are many toll gates. So in advanced countries, what they have is they don't have toll gate. The person has to just move, and cameras are there on top or sensors are there. In the car, there will be a card for the car. So as you pass, it will charge to your car. That facility is there in other countries. So that physically no one will stop you. You just travel, they will charge automatically. Even parking also, it is charged to that car itself there. So many things are there. Even if it comes to our country also, a lot of time can be saved, and a lot of traffic will be fast, and we need it for Bangalore because we are facing in these days all the traffic jam, etc. So mobilization can be done using this approach. Understand what problems face, then think on how to solve them, then identify the technology which can be applied. Solution may lie in many disciplines, not only in one. Then conceptualize it or ideate the engineering solution for that problem, which may involve in many disciplines. And it doesn't mean one has to understand all branches of engineering. One has to understand the glimpse of all engineering, yet in depth your discipline. And wherever you require in-depth expertise in other branch, you can go for a collaboration. Okay, you can always collaborate and use expertise in another discipline. It doesn't mean you have to learn all disciplines, but overall you should know, and wherever required you can collaborate with the expert in other field of engineering. So come up with a project based on conceptualization, then implement and test and routine things, report writing, etc. So based on observation, we can do research, we can find out a new research problem like this. And this is interacting with the surroundings and understand the problem. Some points I will see the surroundings, interact with the people, and since I belong to biomedical and medical data, I have got some medical examples are given. But at the end, I will give some civil engineering examples. I'll solve also. Okay. So see, if you go out, you can see people are suffering with a lot of diseases. They don't have good healthcare facility. And even government also fails because we have very less number of doctors, and ours is a developing country. We don't have many resources to cater the citizens' health needs. So one can develop an AI-based health monitoring system or artificial intelligence-based screening of patients. The thing is, there are many patients in our country who don't get good medical attention. So first stage they can be passed through a AI-based tool where as what AI asks, if they answer, and using algorithms it can be analyzed, and if it is whether his problem is very severe or less severe, not at all severe. So this way it can categorize, and only the people falling in that category can be recommended to the next level, to the doctor or whatever. So in our country, we require paramedical things should develop still a lot. In foreign countries, there are every disease or every abnormality what people face, they have their own community, they have their own group in a city, as well as they have the specialized paramedicals. So they will guide them, and counseling also is available in all diseases in foreign countries. Here also it should come, and AI can be used there. So see the surroundings, interact with the people, find out their problems, and what way one solution can be developed. Solution need not be completely innovative. One can develop an application in a mobile which understands whether the person is moving or not, or what extent he has done the workout, and it can ask what food you are eating or eaten, and with that it can guide elderly persons or person with morbidity. They can be guided using a software routine things. Doctor cannot guide a whole day, sit and guide them. So those are some of the applications. You can design some questionnaire, you can collect the data, see the correctness of the data, then check whether the data is biased or data has some more outliers or data is less, sample size is low or sample size is more, whether the data is having noise or not. All those things can be taken care in that. Established techniques are there with which we can do that. Check whether the data is biased or not, etc. Whether the estimate which we measure using our instrument is it reliable, whether the instrument is having a good fidelity, all those things can be done. And the skewedness of the data. Sometimes data is skewed. Say for example, I have photographs. Okay, so say 10 people's photograph I have. First person I have 20 photos. Second person I have 20. And 10th person I have only one photograph. Okay, so I will see first 10 photos and I will identify this person is so and so. Then second person's photo I will see and compare, I can do it. And it will so happen after 90 photos, the 10th person's photo is only one. I am biased to classify it into one of these earlier seen. So that shouldn't happen. So that is the limitations. So what we have to do is we should have sufficient samples in each data. Even artificial intelligence tool also does the same thing. When your sample size is less, the classifier or your AI is biased to make a decision with the higher number of data available that particular class it is going to provide. So those are the things. The data may be raw, it may be opinion based, it may be numerical, categorical, whatever. Yes. Those things can be analyzed. So I don't describe all the examples because they are healthcare related. Okay. Think on how to solve this problem. First step is you have to analyze the data, identify which mathematical or statistical tool which can be used for that, maybe Fourier transform, Wavelet transform, and the tools can be Python, MATLAB, Scilab, whatever front-end or back-end tool. Then formulate the concept. That is called problem definition. Define the problem, broad idea or abstract it is. Once you formulate the problem, you need to design objectives of that study. Then once you have the objectives, to meet the objectives, what methods are to use? Systematic steps. For an objective, there can be a n number of methodologies, not only one. So that is the thing. So define mathematics of the problem, then use simulation or complete the design, then test mathematical model, then compute and understand the performance of that methodology, etc. Okay, these are the steps. Then conceptualize and ideate the engineering solution for that problem. So you need to develop a design or a system, identify and derive all its parameters. Okay, can be done in the conceptualization. Conceptualization means it is part of problem formulation. So searching the literature or observation or combination, and then what problems are there, identifying, and for that we have that aspect is called conceptualization or abstracting. It is called abstracting, conceptualization or ideation. Okay, and for that idea, we can develop objectives and then problem derivation, then designing the experiments to meet the objectives, and then checking the performance, etc. Yeah, by literature search, these are the steps. First step is one has to select the area of research, search different combination of keywords, different search engines can be used. There are different search engines and there are meta search engines are also available. And if time permits, I will just demonstrate how you can search one or two things which will I explain. Make a database of relevant papers, tabulate important aspects from every paper, see what is the gap, define the problem based on the gap, then conduct the experiments, then tabulate the results, make sure you are able to connect and prove what you have defined at the beginning. These are the steps. Any doubts? Okay. So am I fast or slow? Okay. So selecting the area of research. So here we have to derive the problem from social aspect. Think how you can address this problem. You can design various experiments, block diagram you can represent to define the experiments. Various equipments, measurements can be taken. One example is, my problem statement is, there is a growing need of automated analysis of medical data. This is my conceptualization. How I will solve? I have to develop a methodology using computer, using softwares. I have to code it and then I have to validate that. Okay, so first one is this is the problem definition or ideation or conceptualization. This is how we can develop a mathematical model or proper steps, and finally how we can get an inference and understand about the solution. Okay, so there is a growing need of automated analysis in healthcare. How we can solve it? Using computer programming, MATLAB, Scilab or Python or whatever. And how you can achieve it? Currently we have different microscopes, biopsy in medicine. Like if a person is having a cancer, some cyst or some tumor, they will collect some part of it, some tissue they will collect. They apply various chemicals and they make a slide. Then that slide they will keep under electron microscope, they observe and they see the shape of the cells and their distribution to identify whether it is cancerous or not. Okay, that is done. So currently visually it is done. So we can fit a camera on that electron microscope, and the camera when it captures that can be stored in a computer, and using algorithms it can be analyzed and one can give a inference whether it is cancerous or benign or normal. Okay, so it can be done. So developing an intelligent microscope for histopathology. Histo means tissue science, pathology means disease detection science. Okay, so second step is use different combination of keywords in different search engines. We have various search engines like Google Scholar, then Scopus we have, IEEE Explore we have, so many things are there. We can use different combination of keywords, and advanced search option also can be used. In the advanced search, there is different types. One is keyword based search, one is abstract based search, one is full text search, and one is title search. So the different ways are there which we can use. Just if I put one keyword, more than 1 lakh papers will appear. So from that I have to reduce it 5 to 10 we have to retain, which are very specific to that problem. So from this trillions of papers you are getting using keywords few lakhs, and from that within 10 you have to derive. So this can be done using various search engines, and all our search engines are context based. So whatever you write, it will search and give. And these are different ways, full text or keyword search or abstract search. Here we have to make a database of relevant publications, and we have to see our problem definition, and we have to find out some key aspects from every paper, and we have to make those key aspects as columns, and row wise we should have different papers, and we have to fill each cell of that table. Okay, so make a repository of relevant papers, then use all search engines, arrange them chronologically. Chronological means old is below, new is first, newest, then next, in the descending order of date. So we have to arrange that. Okay, then try to search survey. Suppose if I get a good survey paper in a good publisher, in a good journal, there is a survey paper in 2015. So what I need to do is I will take that as base, then all the papers after 2015 till date we have to search. And suppose if there is a good survey paper in 2020, so I need to search that paper plus 22 till date. So that way it will simplify the task. While reading a paper, also you will get a mention of prominent papers in that area. That is also there. Then tabulate the important information. So one application in my area of research where automated ECG analysis for heart disease detection, I identified these parameters as distinguishing between different papers. One is database. There are various databases available freely online for this purpose. So which database they use and what the size of the data they have considered, part of the data, small part, large part, how many files or how many percent of the main data they have used. Then in the data how many categories are there, then what methods are applied, what is the classifiers they have used or AI tools they have used, and what is the performance they have obtained, then applicability and realizability of that paper to your direction. So this way I can list it for my problem, and with this how I identified the gap and then problem statement I will explain after this. Okay. And sometimes one paper may have a good performance, very high performance, and if you see how much data they have used, must be less data. So when you use large data, performance may reduce. And after you send that paper to a journal, the reviewers may ask why your performance is so high when others have got low performance. So that time we have to justify, and performance is high because we have considered only less data. When you go for complete data, you may get a less performance. That way you can justify. Say I have opened large data and I got a less performance. The reviewer may say others have got 70%, you have got lesser than that, why it is last? That time we have to justify. In that paper this much percentage of data was used, but here we have used more than that data and we have covered more diverse examples, and because of that my performance has reduced. And today we also have machine learning, deep learning and all we also have explainability of the data. Yeah. We also have explainability of the data, so with which when you include explainability, the performance will be even reducing. It will reduce. But reason is you are including explainability. That is called in your artificial intelligence new branches explainable AI. Okay, this this is the table which I prepared based on important papers in that direction. You can just see. Okay. So the first paper. The first paper, Hu et al., they used some time domain features. The data was time series. With respect to time, I was getting values. So that waveform is called a time series data. So time domain key parameters we have extracted from that, and some classifier is used, mixture of experts. Only two classes he has used, so he got 94% of performance. The other one using Hermite function and some classifiers, he got 98.51% and classes were 25 in that. And this performance was not mentioned by the author in that paper. What I did is he had provided a confusion matrix which data is classified into which class. From that I had derived, so I have made it star here. And the third one is higher order spectra analysis, and some methods are used.